Hi, everyone. Thank you so much for your patience. I think we kept it a little shorter than the announced 7 to 8 minutes, so we're now here for our next session. And for everyone who's still in the back, I'm happy to invite people over. Everyone joining us in the room, thank you so much for joining us for this session. It's the last one before lunch, so you can already look forward to that. And at the same time, I'd like to thank everyone online as well for joining us. As said, I'm Laurens Cyrullis. I'm Politico's Deputy Tech Editor. I work with tech reporters on all issues of technology, including microchips, one of the things that has taken up quite a bit of our attention in the last years. I have the pleasure of moderating our next session, which is a spotlight discussion that looks at how Europe can successfully green its microchips supply chain. And before I introduce our guest for this session, I want to remind you that you can interact with the session on the application called SwapCard, which is on our events page online. And you can also interact with the people at the conference using social media, like X, but also like others. Other social media have gathered a little bit more enthusiasm in the last year or so. So you're happy to talk there about our event. Joining me on stage is arguably the EU's best-placed chips official. We've got from the European Commission, Lucilla Scioli. She's Director of Artificial Intelligence and Digital Industry at the Commission's digital department called DG Connect. Lucilla, if I can invite you on stage. Have a seat.
Hello.
So first of all, thank you, Lucilla, for joining us.
Thank you.
Lucilla, you are what I can describe as the architect of the CHIPS Act. Perhaps you will scuffle at that, but you were at the center of the drafting of the European CHIPS Act, which is a central piece of legislation on chips technology, and arguably one of the most ambitious and grandest industrial policies that we've seen coming from the European Union in the last decade or so. I wanted to just mention that we would have had Henrike Hahn, a German member of the European Parliament, who was also central at the discussions on the CHIPS Act. Unfortunately, Ms. Hahn had to cancel due to an unforeseen medical urgency, preventing her to be on stage. But we will have a very interesting discussion. Before we launch into it, we can have audience questions, so I do invite you to think of a question if you have one, and somewhere halfway through our discussion, I will invite you to intervene if you wish to do so. But let's turn to the discussion on chips. So first of all, I think it's important to start with the basics, which is the European CHIPS Act is now in place. It has been passed, and it is in full motion. It's already attracting investment in the chips industry in Europe. As we're talking about sustainability today, I think it's good to start with what the Commission envisioned the CHIPS Act to be when it comes to a sustainable future for Europe. Because there's two elements to this. The CHIPS Act also plays a very important role in greening industry all through Europe. So Lucilla, if you can address that question, what role does the CHIPS Act play in sort of Europe's sustainable future?
Well, thanks a lot for this question, because it allows me maybe to explain a couple of aspects of the CHIPS Act that don't get highlighted very often, which is, first of all, the fact that, just as a reminder, the CHIPS Act is organized around the 3 pillars, and there is one of these pillars which looks at stimulating investment in factories in the European Union. In factories that are particularly manufacturing chips, of course. And these factories, most of these factories are very costly and are publicly supported, at least partly. And the conditions that we attach into the state aid assessment for allowing this kind of public support refer to what we call the first-of-a-kind production. So basically, we allow public support of these factories if they can show that they are first of a kind in terms of innovation. And the innovation can, of course, relate to the product they produce, but it also relates to the technology they use in the factories, because as we go towards more advanced factories, the technology is more and more efficient, also in terms of environmental impact. So one of the main ways of showing that a factory is first of a kind, for example, is to show that it uses more energy efficient, better recycling of water, better technologies, generally speaking, in terms of the environmental impact. The other aspect to highlight is the fact that chips themselves have a very important environmental impact, and here I'm talking about environmental impact they have on the devices and on the machines they actually apply to. And chips, as you know, apply everywhere now in our society, and any kind of smart device will contain a chip. And when we hear about the chips being more advanced, smaller, and so on, we also refer to chips that become increasingly more energy efficient. So for any given size, the smaller chips are actually much more efficient than the more mature chips. And also there are new technologies, for example, called FDSOI, and we are one of the first of a kind factories that will be developed in France, for example, is dedicated to FDSOI, and the FDSOI is a technology which has been developed in Europe, where Europe is particularly strong. It's a technology of chips. It's some kind of chips that are particularly energy efficient. So I think all these elements have to be very much taken into account. Just one more element is that probably the first of a kind project we have approved, which is in Sicily, in Italy, is on silicon carbide. So there is also this trend in the manufacturing of, in the production of chips, of using materials like silicon carbide or gallium nitride, which are used for power electronics, for cars and so on, and which are very energy efficient. And so that's why they are being used, and Europe is actually specializing very much in the use of these new materials.
Mm-hmm. These are interesting examples, I think. If I may ask, I think a lot of the discussion around the European Chips Act has gone to the mega fabs that are announced and hoped to take place in Europe. There's one announced by US chips giant Intel in Magdeburg in Germany. That's one of the flagship projects that Europe sort of drew to its borders. As part of the CHIPS Act. Are you seeing the examples you mentioned, are you seeing the same impact on sort of the mega projects, the mega fabs that are taking place, and how are those projects adapting and making their pitch?
Well, certainly the companies, when they build new factories, they tend to build factories that are increasingly more energy efficient. If you look at the amount of recycled water, and I'm referring to water because the production is particularly water intensive. You see that in the past few years there has been a huge improvement in the amount of water that is recycled, and also much more energy efficient as we go on, because also the way these factories tend to be, they use renewables basically to get their energy from. So there is a clear trend and a clear commitment also from the companies that they will be climate neutral, that they will be, carbon neutral, that they're really making an effort in becoming as energy efficient as possible. And I think this is a very important element in the projects that they are carrying out.
Mm-hmm. Now, if you talk about greening the microchip supply chain, we've got to talk about forever chemicals, in part because this discussion has come up more recently than the drafting of the CHIPS Act actually took place. But it is an essential to some in the chips industry, perhaps threatening development. So I just wanted to ask, from the European Commission's perspective, first of all, seeing this discussion on forever chemicals and PFAS take place right now, what is your sense of the discussions you had on the CHIPS Act when it was being drafted a couple of years ago? To what extent was this built in, or to what extent was this aspect looked at and taken into account when coming up with the European CHIPS Act?
Well, the European CHIPS Act doesn't look at any particular chemical or manufacturing process or level of water consumption. It simply, as I said, tries to drive a better and cleaner way of producing semiconductors through its first-of-a-kind objective, through its funding under the first pillar, where we fund innovation in the technology. And of course, as I said earlier, innovation also goes through using more energy-efficient and cleaner technologies. And the question of PFAS, in reality, has been on the table for some time. What happens with PFAS? The PFAS is, these chemicals that are used by, I think, in many applications in electronics as well, and in the production, in the manufacturing of chips as well, although in not very large quantities, because it's used only some PFAS for some very specific applications. But what we are doing here now is to look for alternatives for this kind of chemicals. At the moment, alternatives for these chemicals for production of semiconductors do not exist. So we are engaging in research projects on this. It will take a few years, because it's research projects, of course, take a few years. But it's a reality that at the moment we don't have an alternative. And so we are very much engaging at the research level and also at the international level on these aspects. We are actively discussing, for example, with the United States in the context of the Trade and Technology Council for collaborative research on PFAS. We are doing the same with Japan in the context of the digital partnership. And so this also shows that there is an international awareness of the problem, and that it may take a few years before we actually have an alternative to the PFAS that is actually used by the manufacturing of semiconductors.
And on that aspect, on the aspect of international cooperation, what's been the response from other partners and other regions in the world that you've seen on forever chemicals specifically? Because there is, of course, a danger that this becomes a comparative disadvantage for Europe if we go full steam in making sure that we draft legislation to deal with this issue, but other parts of the world do not. How is the Commission sort of trying to work its way out of that situation?
Well, there is an awareness of the issue, but it is true that the European Union at the moment seems to be the only continent where we are having a discussion on whether these chemicals should be banned completely, or whether some. We are working here now in the framework of the REACH regulation. So, as you know, some derogations can be allowed for certain industries that have a very specific impact. This is all still under discussion, because the Chemical Agency, as you know, is now collecting input from stakeholders to make up their to gather information and then analyze it through a scientific community whether they should, which are the actions they should take in relation to this particular problem. In the other continents, they are not having the discussion at this level. There is an awareness and there is an interest, of course, in participating in research to be able to collectively come up together with alternatives, because this is the only solution to the problem. Semiconductors, I think, they are a really critical technologies. We have it everywhere in our life. We saw during COVID what happened when all of a sudden we had shortages. about semiconductors. And then there were many basic things that we couldn't do. And then there are problems in hospitals because, there are problems in many of our critical infrastructure. So it is an area where we need to find a solution, and I think that international collaboration is the best way to find a solution at the moment.
And maybe as a last question, do you have a sense of the timeline for alternatives right now? Is that something the chips industry is giving you input on what they see as a realistic timeline to actually turn this around?
Well, there is no definite timeline because, as you know, research is not deterministic. So, but I think it will take a few years. It can take from 5 to 10 years before we can find alternatives, in my opinion, to these chemicals.
I'm going to have a quick look around to see if there's one question from the floor. There's several questions from the floor. If I can give the word to you.
Yes, is this working? Yes, hello. I'm Ioana Bere from ChemTrust. I just had a quick comment regarding the alternatives of PFAS in semiconductors, because I actually read very recently an article on alternatives to PFAS. It was developed in the US. The company is called Transcend, and in fact, they worked a lot with a university in Massachusetts. So this is what helped to come with these alternatives to PFAS in semiconductors. And I think, in view of what you said, it's very important to still invest in research and this international collaboration. As there is this alternative in the US, it would be nice to further develop it, scale it, and bring it in the EU as well.
Thank you very much. And indeed, that's why it's important to do international collaboration, because there are new discoveries coming up also in other continents. So it's very important to do that internationally.
I have one more question from the sir here.
Okay, stand up for the camera, please.
Yeah, hello, my name is Matthias Müller. I'm from the European Semiconductor Industry Association. Yeah, I just wanted to give more of a comment, maybe than a question. And of course, I would be delighted to hear your reaction. And I also wanted to give a quick reaction on the previous question or comment, actually. Yeah, what I wanted to stress is that you brought up the lack of alternatives that is very much present at the moment. Yeah, in the semiconductor industry, we have been researching alternatives already for more than 20 years without success in many cases. In some cases, there have been successes. So this, I really want to stress these processes take time and a lot of research, and there's no guarantee for success to identify alternatives, also because the different uses are so wide. So we have the PFAS in process chemistry, we have PFAS in specialty plastics, so fluoropolymers, and the difference, there's no one size fits all. And to your comment on this research from university in the US, of course the industry is aware of that, but this is an alternative at a research level for a very specific use case. And of course, when we talk about this fundamental research, this does not mean that it's a drop-in alternative that you can just drop in a fab and it solves the problem. This has to be upscaled to industrial use, and this is something that I notice that is often forgotten if we talk about alternatives. It's one thing to develop something in a lab, it's a completely different story to put it on an industrial scale into a fab.
Thank you very much.
So I'll leave it at that.
That's very helpful. I didn't hear a question. I have one last one for you, and then we close because we're keeping you from lunch. What I wanted to ask is, a big part of the European Chips Act was the promise that Europe wanted to gain 20% of the global value chain in chips in the semiconductor industry by 2030. That promise was made, I think, 2 years ago now that it was confirmed. I wanted to ask you, looking at the situation today, would you have put a different target there, considering the discussion we're having on forever chemicals?
Well, this question almost amounts to say, should we stop investing in chips because we have the problem of the chemicals? And should we, we have set that objective because for us, the resilience of the semiconductor industry in the European Union is extremely important. And it remains important. As I was saying earlier, we experienced it during COVID, what it means not to have the chips that you need. And nowadays, if you want to have electrical vehicles on the road, you need to have thousands of chips. If you want to have renewable energy, you need to have a lot of chips. If you want to have photovoltaic, you need chips. I mean, for everything, you need chips. So you will not be able to do the green revolution and the green transition without having the chips. But at the same time, we cannot be in a situation where we depend on a couple of countries in Asia for the development of these chips, because it's enough that big continents like the United States and China decide, as they have, that the chips are a very geopolitical and strategic instrument, that already there will be problems, or there can be problems of disruptions. So you see, there are reasons for which we need to be able to manufacture chips in Europe because of the disruptions that could take place abroad. And it doesn't mean that we become anarchic. It also means that we just have to strengthen a little bit what we are doing in the European Union. We are not talking of a factory in every country. We are talking of very few factories, or strengthening also the factories we have in the European Union. We think it's essential for the resilience of the semiconductor sector that we absolutely need if we want to be able to make the green transition. Because I think it's okay focusing on PFAS and other environmental impact of the semiconductor industry, and we have to green it, and there is a strong commitment to do that. But I think it's equally important to always remind of the importance of more efficient chips for the green transition, because they power all the devices that we have and that will help the green transition themselves.
Thank you very much, Lucilla. I hear the target stands, so that's we'll look forward to 2030. I'd like to close this session. Thank you all for joining us. I'm handing the word to Jan Cienski, who's going to close our morning session, and then you're very much welcome to join for lunch. But first, Jan, thank you very much.
Thanks very much, Lawrence. I'd also like to thank all the panelists and moderators who took part this morning and who really brought home the deep political divides over technology and innovation and the EU's green transition, that tension between maintaining very high and imposing higher standards within the EU, or farming out production abroad with the concomitant environmental and political risks that involves. We really got a good flavor of that on the Green Innovation panel, where we heard, on the one hand, the benefits of genetic engineering and pitless cherries, and the other one where that potentially endangers 30 years of biosafety rules. The other panels also highlighted the tensions between markets and regulation in the effort to go green. I hope that all of this gives you some food for thought for our lunch break. We're going to break until 1:55 this afternoon, and when we come back, we'll be talking about the circular economy, and I'm going to hand over as Master of Ceremonies this afternoon to Sustainability Editor Esther King. So thanks again for this morning, and see you in a little while.
This is an age of disruption, of profound revolutionary change.
What we're really asking ministers is to empower the ambassadors.
The only thing that you really push forth is the truth.
You don't see many women represented when it comes to the decisions as to how to handle the pandemic.